The Earth's rotation is slowing down, and it might just cost us a second in the near future. Here are the facts we know about this mysterious phenomenon. In 1962, the Earth lost 1 millisecond of its rotation, according to measurements from satellites orbiting our planet. This observation was made possible by tracking radio signals sent out by Navy ships around the world. And since then, scientists have seen the length of a day fluctuate from the effects of earthquakes, tsunamis, volcanic eruptions, storms, and even the melting of glaciers. But no one had ever noticed anything like this before. And while the loss of a single millisecond doesn't sound like much, it's actually enough to make our current global timekeeping system fail if it happens again. So here's what's happening, why scientists are worried, and how we can fix it. To understand how Earth could lose an entire second, we first need to look at our planet's spin. We generally think of Earth as a solid ball spinning through space, but our planet is mostly liquid. As the Earth rotates, that water sloshes around and shifts our planet's mass distribution. So Earth isn't really rotating as a single unit. It's more accurate to think of it as rotating with a slight wobble. And it turns out the sloshing water isn't the only thing affecting our planet's spin. The atmosphere also affects the Earth's rotation speed, along with wind patterns, ocean currents, and even the way people use energy. For example, when an earthquake strikes, the energy released changes the Earth's rotational speed. Or when storms blow around Earth's surface, they can speed up or slow down our planet's spin depending on where they form. But while we've been able to measure these shifts in our planet's rotation, there's one thing we haven't accounted for yet. The Earth's gravity is slowly pulling water away from its equator and dumping it near the poles, which means our planet is getting wider at the same time it's getting flatter. And this redistribution of mass affects the Earth's rotation. Now, we don't know exactly how much water is moving from the equator to the poles, so we can't say exactly how fast Earth's shape is changing. But we do know the effects are real. Between 1993 and 2010, the Earth's equatorial bulge shrank by about 3.5 kilometers, and as a result, the planet's rotational speed increased by 6.1 centimeters per second. That might not seem like much, but it added an entire second to our planet's rotation. And if the Earth continues to shrink in size, we could start losing seconds over time. On average, the Earth has been losing about 270 microseconds per century, which isn't enough to worry about yet. But in 1962, Earth seemed to lose almost 3 times that amount in a single year. So while we're not sure what caused the sudden loss of time back in 1962, it could be a sign that something similar is happening again. Now we have satellites that can track our planet's rotation much more accurately than we could 60 years ago. And while researchers have spotted some blips in the data since 1962, nothing compares to what happened that year. In 2020, Earth actually gained 2 milliseconds, which may have something to do with how warm ocean currents moved around the globe that year. But scientists would like to get to the bottom of this because the Earth's changing shape will eventually have serious implications for our timekeeping. Eventually, the shift in Earth's shape will cause our planet's rotation to slow down enough that it won't sync up with our current timekeeping system. Right now, our time is based on 86 hours and 400 seconds in each day, but as the Earth's rotation slows down, we'll need to add a second to every day. The last time we did this was in 1905 when we added the 24th second to our current timekeeping system. But it's not quite that simple. In order to add a second, most of the world would have to agree to leap seconds, which are extra seconds added to coordinated universal time. They happen less frequently now, but between 1972 and 1990, they occurred roughly every 18 months. And while that might sound convenient, adding an entire second to every day wouldn't work for everyone. Satellites rely on incredibly precise timekeeping to function properly, and GPS systems would go haywire if we suddenly started adding an extra second to every day. So instead of adding an entire second, scientists could tell affected parties to drop a single second sometime after June 2024. While that sounds pretty crazy, it's actually happened before. On June 30th, 1972, the last negative leap second was enacted, dropping an entire second from the last minute of the day. It's not exactly clear who decides when we drop a second, but it's likely that the International Earth Rotation Service, a group responsible for monitoring the Earth's rotation, would be in charge. But this solution isn't ideal either. Dropping a second from the end of the day is already difficult for computers and other electronic devices. Doing both would be too confusing and cause too many problems. So scientists are looking for solutions that don't involve adding or removing an entire second. One option is to split the last minute of the day into 61 seconds and 59 seconds. That way, we wouldn't have to change our current timekeeping system and all electronic devices would function normally. Of course, splitting a minute in half would probably lead to all kinds of confusion as people wondered why their clocks were showing 61 seconds instead of 60. But if we made the change gradually, perhaps by starting with 60.1 seconds, the public could adjust without realizing it. There are even crazier options out there, like splitting the day into 86,400,101 seconds. With this system, we would add an extra hundredth of a second to each day, eventually making up our full second. Of course, people would notice this extremely quickly, which could lead to all kinds of chaos. While we don't want to jump the gun and make any drastic changes to our current timekeeping system, it's important that we figure out what's causing Earth to lose time. These observations could help scientists develop better models of our planet's rotation and give them insight into things like ocean currents and climate change. And if it turns out that the Earth isn't losing time, we'll still have a whole host of new data that we can use to improve our understanding of our planet. So it might be worth keeping an eye on the clock just in case. Thanks for watching this episode. We've made thousands of educational videos over the years, and we've been able to offer them for free because of our patrons. So to all of our patrons, thank you for what you do to make this happen. If you're not a patron but you want to learn more about what that means, you can go to our support page.